So this video lesson is all about comparing fractions and mixed numbers. By comparing, we mean deciding which ones are greater or less than the other, or ordering a set of fractions or mixed numbers that we have so that we can determine which is least, which is greatest, and where the numbers fall in between. So first, let's look at a few scenarios where we might want to compare numbers. So if you think as part of a city softball league, if Team A has played 10 games and won 7, Team B has played 10 games and won 8, which team is doing better for the season? Which would you say has a better record, perhaps? Go ahead and pause the video, see how you might want to compare how these teams are doing, and then unpause when you're ready to go. So one way that we could consider talking about which team is doing better is by comparing the fractions of games that they've won to the ones that they've lost. And in this case, the fact that or rather to the games that they've played. So in this case, considering that both teams have played 10 games, we can just outright compare Team A has won 7, Team B has won 8, and since Team B has won more games, both cases out of 10, since Team B has won more games, we could say Team B has a better record for this season. Now think about this scenario. Team A has played 8 games and won 6 of them. Team B has played 12 games and won 8 of them. How might we compare these two records? Well, it's not quite as simple because Team A has played 8 games, whereas Team B has played 12 games. So if we look at the fraction, that is the games won divided by the total, which will tell us the fraction of games that they won. Team A has won 6 out of 8. We'll say that Team A is in purple. Whereas Team B, who will be in red, has won 8 out of 12. Now we can't immediately just look at this and say, well, Team B has done better because they won 8 games, and Team A has only won 6, because Team B has played more games. Team B has also lost 4 games, and Team A has only lost 2. So it's a tough thing to try to decide. So one thing that we can look at is what happens if we put both of these fractions in simplest form. Well, 6/8 is the same as 3/4. 8/12 is the same as 2/3. And if we remember how to compare fractions where the numerator and denominator are just off by 1, like 2/3, 3/4, 4/5, the bigger the denominator, the bigger the fraction when we have only 1. So 3/4 is actually greater than 2/3. But if we want to find a way of really saying this, we would have to find a way of comparing these fractions. Now, the fractions we had before, where they were both out of 10, are very nice because Team A then would be 7/10, and Team B would be 8/10. So we might want to consider taking these fractions and finding a common denominator. Because if we have a common denominator, we can tell exactly which fraction is greater. So start with 3/4 and 2/3. Now 3 and 4 both go into 12. So if we multiply 3/4 by 3 in numerator and denominator, because that's how we create an equivalent fraction, we see that this is 9/12. Whereas B, we can multiply both by 4 and get 8/12. Now these two fractions we can compare. 9/12 is greater than 8/12 because they have the same denominator, and 9 is greater than 8 as the numerator. So Team A has won more games because the same fraction as 6/8 can be represented as 9/12, and of course 8/12 is 8/12. So then what about something like this? Last one. Team A has played 12 games and won 9. Team B has played 8 games and won 6. Pause the video, see if you can figure out which team is doing better for the season, and then come back when you're ready. So Team A has won 9 out of 12, which is the same as 3/4. And Team B has won 6 out of 8, which is also the same as 3/4. So apart from saying, well, maybe Team A is doing better because they played more games, if we're looking strictly at the fraction of games that they've won, they are actually equal. And we know they're equal because we've taken both fractions, reduced them to their simplest form, and in this case, they have the same denominator. Whereas if we look back at the other fractions that we were looking at, 3/4 and 2/3, we simplified them down to simplest form, but then found a common denominator, and we're able to compare the numerators to determine which fraction is greater. And so what we've done is actually the method that we use for comparing fractions. It involves two pieces of vocabulary. First, a least common denominator. The least common denominator of any two or more fractions is just the least common multiple of all of their denominators. It is something that we can change each of the denominators into and is the smallest such thing. And then when we compare two fractions with different denominators, we find the LCD, convert to the LCD. So like we did with 6/8 and 9/12, we converted to 8/12 and 9/12. And compared their numerators to determine which fraction is greater. So go ahead and pause the video, write down both of these two definitions that are getting yellow stars, and unpause when you are ready to come back. So let's take this strategy then and compare a few fractions. These two fractions here, 3/8 and 5/12, 11/20 and 5/12, and we'll take you through how to do each of these. So for 3/8 and 5/12, we would need to find out something that both 8 and 12 go into. Now the LCD of 8 and 12, 8 is 2/3, 12 is 2 squared times 3. So we need 3 2's and a 3. 2 times 2 times 2 times 3. Our LCM is 24. Again, remember, with the LCM, we look at the greatest exponent for each of the prime factors and compare them. If you need a review of that, go ahead back to your notes or to the video lesson for LCM. So 3/8 is going to be the same as 9/24, because we have to multiply numerator and denominator by the same number to create an equivalent fraction that doesn't change its meaning. Whereas 12, we only have to multiply by 2, so we get 10/12. Because 10/12 is greater than 9/12, that means that 3/8 is less than 5/12, or 5/12 is greater than 3/8. Because we changed it to their least common denominator, 10/24 rather, change it to their least common denominator and compared those denominators. Now let's look at 11/20 and 5/12. So we have that the LCM of 20 and 12, well, 20 is the same as 2 to the squared times 5. 12 is the same as 2 squared times 3. We need 2 2's, a 3, and a 5 to work with this, so the LCM is 60, which means that the LCD is 60. 11/20 is the same as 33/60, and 5/12, multiply both by 5, is the same as 25/60. Because 33/60 is greater than 25/60, we know that 11/20 is greater than 5/12. So go ahead and pause the video and see what you can do with comparing these three sets of fractions: 5/12 to 7/18, 7/10 to 3/4, and 3/8 to 11/15. Pause the video, come back when you're ready. So for 5/12 and 7/18, the LCM of 12 and 18 is 36. That's what we're looking for. 12 is 2 squared times 3. 18 is 2 times 3 squared. So we need 2 2's and 2 3's, which gives us 4 times 9 is 36. So 5/12, multiply numerator and denominator by 3 gives you 15/36. 7/18, multiply numerator and denominator by 2 gives you 14/36. 15 is greater than 14, so 5/12 is greater than 7/18. 7/10 to 3/4, the LCM of 10 and 4 is going to be 20. We can see that because 4 is 2 squared, and 10 is 2 times 5. We need 2 2's and 1 5 to make the LCM, and that gives you 20. 7/10 multiply numerator and denominator by 2 is 14/20ths, whereas 3/4 multiply numerator and denominator by 5 is 15/20ths. 15/20ths is greater than 14/20ths, so 3/4 is greater than 7/10. And finally, looking at 3/8 and 11/15, you might be able to look at this and say, well, 11/15 is greater than a half, and 3/8 is less than a half, so obviously 11/15 is going to be greater. But if we're looking at this from the LCM perspective, the LCM of 8 and 15 is going to be 120, because 8 is the same as 2 cubed, 15 is the same as 3 times 5, so we need 3 2s, a 3, and a 5, and we multiply all that together, we end up with 120. So 3/8 multiply both by 15 and get 45 120ths. 11/15 multiply both numerator and denominator by 8, which is 88 120ths. 88 is very clearly bigger than 45, so 11/15 is greater than 3/8. Finally, last two problems. We're going to order these fractions from least to greatest. So in order to do that, I'm not going to give you too many directions on it right now, but consider how we might use the LCD to compare the fractions. We want to, again, order the fractions from least to greatest. Go ahead, pause the video, come back when you're ready. So for the first one, where we have 3/8, 11/24, and 5/12, the LCM of all three of them is to change them into 24ths. Multiply each of these by 3, we get 9 24ths. Multiply each of these by 2, we get 10 24ths. So, from least to greatest, we have 9 24ths, 10 24ths, and 11 24ths, which means that 3/8 is less than 5/12 is less than 11 24ths. And this is the order of the fractions from least to greatest. Finally, for this last one over here, our LCM is 16. So if we multiply each of these by 4, we end up with 76/16. Multiply each of those by 2, 35/8 is the same as 70/16. And 4 and 7/16, we need to have a way of converting that to an improper fraction. So this 4 represents 4 sets of 16/16. So that's 64/16 plus the 7 that we have already gives you 71/16. If you need a review of converting mixed numbers to improper fractions or improper fractions to mixed numbers, there will be a video lesson on it soon, and there will also be questions in class, so go ahead and write that down as a question that you have and bring it to class. 70/16 followed by 71/16 and 76/16 is the order from least to greatest, so we have that 35/8 is less than 4 and 7/16 is less than 19/4. So two different ways to write down the ordering, one with commas that just order them from least to greatest, and the other with the less than sign. But again, brief review to compare fractions and then to continue on to ordering them. We want to find the least common denominator, or any common denominator really, but the least is the one that we are really interested in because it's the lowest. And then convert those fractions to least common denominators and compare their numerators. Because once the denominators are the same, the smaller the numerator, the smaller the fraction.